Hello everyone, my name is Owais and today we'll be doing a project on a trend analysis related to data science and foundation. So, trend analysis, we need to analyze trends in data where this is our data, these 7 Excel files. So these Excel files contain cutoff ranks of K-set of round 1 from 2016 to 2023. Let me just open and show you one of the file. So here trend analysis, we need to actually identify a particular college. So here I can identify this. Let us take E004 Dr. B.R. Ambedkar Institute of Technology in Bangalore. In this college, I need to select three different branches. So let's go for the first three branches, that is civil, computers and electronics. And I need to filter analyze trends for a particular category only. So I will select general merit category. Here actually in general merit most of the time all cutoffs are released. Sometimes in other categories cutoffs are not released. That's why we are going for general merit category. And now let us understand how we can proceed with this trend analysis using PyCharm. Now I am using PyCharm IDE. Here this first we will initiate our file location to our code. So this is the location of the file which contains all the Excel files. So in PyCharm I'll just give this location, and I can actually specialize this location for only Excel files by putting this like a filter thing. And we'll first import glob. So glob is a Python library, as a usual Python library that is used to extract multiple locations in a file. So if I initiate this Excel files and glob file, so it will generate all the locations of the Excel files that is present in the folder. So now we need to initialize a list for years. So from 2016 to 2023 we have initialized a list, and in order to extract data and manipulate it from the Excel files, we'll import pandas as PD. Pandas are usually used for data frame management and data analysis and using for data sets. So now we'll just create an empty data set. We'll initiate a for loop for which Excel files, where we have actually stored our Excel files, we'll read the Excel files using panda function read underscore Excel, and this is a location. So this .loci which we are seeing over here, this we can use through pandas actually to to navigate through rows or columns in Excel files. So for I in range of length of df2, so df2 is actually what we have read the Excel file complete whole thing, so that will be the length of the complete Excel file. So for I in range of the complete length of the Excel file, if if any cell that has a string that starts with E004, so E004 is actually our college. The college that I have selected is actually the code of the college. So each college has a particular code. So my college will have E004 as a code, and each college will have its own code. So this is the code of college that I have selected. So I'll just initiate a flag over here. So by giving this, I'll initiate a flag, and after this I can do slicing for the data set. So .any is like any data format after this flag. I need to read it. So we are doing slicing from, this is our I location. So slicing we are doing from I+1 to I+5. So I+1 from here to I+5 till here. So we are performing slicing for CE, CS and ECE electronics, and therefore also we need to slice through columns also. In order to slice through columns, we'll just initiate a flag named GM. So the whole column of a general merit category will be sliced, and we can initiate like integer only for like cutoff ranks. Mostly integers only will become. So if length, we actually can ensure that our data set does not increase, does not have more values than 3. So we have selected 3 branches, so we need only 3 like data values. So we can like ensure this by putting this if condition. And here we are converting we are rearranging the data from the Excel file into a data format. So data one dot append years comma year. This year is actually from the data set that we have given here, list, and CE civil values dot I location of 0. So, and similar for CS and electronics. Here after this, if we print this data, we'll get something like this. So years will be printed over here in this format, and CE civil will be printed over here in this format, and CS computers will be printed over here in this format. Same for electronics. We will print this data for using the print function. Now after the data is extracted in the desired format, we can go with plotting the raw data. So we need to visualize this raw data first. So we'll just we'll import a matplotlib.pyplot as a PLT, and we'll plot for CE, CS and electronics. After that we have to perform a linear regression. So in order to perform linear regression, we are importing stats from SciPy library, and in stats to perform linear regression, this is the function. So we will call this function. So when we call this function returns us 5 values actually. So these are the 5 values that a function will line regress function will return. So from slope, intercept, correlation coefficient, p-value, and standard error. So for each data set, so we have 3 data sets now: CE, civil, and CS and electronics. So for each data set, we'll repeat this step, and we'll actually extract slope and intercept. We need actually slope and intercept for our line fitting. So after getting slope and intercept, we can create a fitted line for our this thing data set. So in order to create this, we'll just multiply the slope, whatever of slope of civil, whatever slope that we have got from this line regress for civil, we'll multiply it with the rearranged data format, and we'll add it with the intercept. So this is basically like mx plus c. So here is our intercept, and here is our slope, and this is the data set. We'll perform this for all 3 branches, CE, CS and EC. Once this is done, we'll plot the fitted lines. So here plotting is done. And rest of the things are like plotting only. So yeah, first we'll plot our we have already plotted our raw data set. We have already visualized it. Now we need to visualize how our linear fitted lines are going. So in order to do that, we'll just plot over here linear lines, or linearly fitted lines. Then after that, we'll plot both the raw data set and the linearly fitted lines as a final graph. So this is for the raw data set, and this is the plot for linearly fitted lines. After that, we'll just give the label, title, and legends, and let us see while running the code. Okay, so we have got our desired data format over here, and this is the first plot. As you can see here, this is the first plot that we have gotten over here. So this is raw data for extracted data plot. As you can see, this is the trend that is going through. Now we'll close this and we'll get the linearly fitted lines data set actually plot. Yeah, so here as you can see, the SciPy, so linear regression, after linear regression the plot is looks something like this. So these are the linear fit lines for CE, CS and electronics. As you can see, civil is more like civil has actually increased trends in cutoff ranks. So cutoff rank has been increased over the years for civil. Not much for actually computer science. Computer science remains very low, and EC, you might say that it increases like not much, but there is slight increase in the EC cutoff rank, as you can see from this linear regression. So as you can see over here, this is the imprinted line fittings of our curves. So this is actually the data set of our raw data, and this is the visualization of linearly fitted lines for each curve. So this is what we can actually analyze from this code and assignment. So thank you for your time, and we'll see you in next video. Thank you.